Hi everyone. So I was asked by a student this question right here. What is the exact value of the tan of 5 pi over 6? So that brings up the question, obviously, what is tan, first of all, and where do I get the exact value? So first, I'm going to quickly remind you, I'm sure you remember, that tan is the ratio between the opposite side and the adjacent side. So we're not getting into context right now, but for whatever reason, when you're looking at a situation that involves tan, you want to know the ratio between opposite and adjacent. And what I can remember from last year, let's say the height of something and its shadow. Okay, and so on and so on. Now, I'm going to show you that there's another way to think about tan, and tan is also equal to the sine of an angle between it's the ratio between sine and cosine. Okay, so I'll show you quickly. Now, if sine is opposite over hypotenuse and cosine is adjacent over hypotenuse, we can simplify this. How do we simplify? To divide by a fraction is to multiply by the reciprocal. We can simplify even further, and there we see that they are equivalent. So you can find tan by either dividing the opposite by the adjacent if you have the measurements, or if you don't have the measurements of the sides that you're setting, you can find tan by dividing the sine and the cosine. So really, tan is actually somewhat indirectly, it's indirectly in the unit circle. Okay, and I'll show you how. It's in the unit circle because of this relationship. Okay, remember that the unit circle gives you the sine and cosine of certain certain angles. So I'm just gonna quickly, I'll do one. Okay, so I'll do, let's do here, pi over 6. Pi over 6 is root 3 over 2.5. Okay, we have 0 here. This one is, let's do the easy one. This one is 1, 0. Okay, so I don't have the whole circle here. Remember, you should memorize it. See, so if it's memorized, you can bring up the part that you need whenever you need it. But for now, I'm just going to use this one point. So if I ask you, I know it's not the one at the top, but it doesn't matter. This is still a good example. If I asked you for the tan of pi over 6, the unit circle gives you, remember, cosine and sine. So what do? We take the ratio of sine first. Okay, so it's this order is cosine sine. Sine is the opposite. Sine over cosine. Sine first and cosine later. Remember, dividing by a fraction, multiplying by the reciprocal. We have 2. No, sorry, we don't need the 2. Those cross out. 1 over the square root of 3. Irrational. Multiply numerator and denominator by a value of 1, but that is always the denominator. So 1 times the square root of 3 is still the square root of 3. The square root of 3 times the square root of 3 is the square root of 9. And I'm just going to skip that step, root 3 over 3. So the exact value of the tan of pi over 6 is root 3 over 3. Now, remember, all these values repeat. Okay, so let me just put First, the 4 easy ones. This is pi over 2. Pi over 2, we have 0, 1. At pi, we have negative 1, 0. And at 3 pi over 2, we have 0, negative 1. Oops, negative 1. So I'll choose another color here. I'll choose green. So I'll just put the tan here in green, okay? So the tan here, sine over cosine, y over x. 0 divided by 1 is 0. So the tan here is equal to 0. Y over x. The tan is undefined. Okay, the does not exist. So that would actually be an asymptote. Okay, so eventually when you study the function, you'll see that there is no tan for those angles. Here we have also 0. And here we have undefined as well. Where am I getting these values? Sine over cosine. So let me just quickly go over this one here. Sine is negative 1. Cosine is 0. That value is undefined. Let me do another one. Okay, I won't do the whole circle, but I hope this is helpful. How about the tan of pi over 4? Okay, I'll try to do 3, because once I do 3, you'll see that the values always repeat. Pi over 4 is right here. The fourth's super easy. I know this is getting messy. Root 2 over 2, root 2 over 2. And you're going to see how easily this simplifies. Anything divided by itself is 1. Which should make sense, because in an isosceles triangle, 45 degrees, the opposite and adjacent side are equal. So if you compare them, the ratio is 1. It's the same side. So that was one tan. This is another tan. And if I can do it up here, the tan of pi over 3. So pi over 3 would be here. Let's see now if I can just erase and make some space there. So pi over 3 is right here. This is pi over 3. This is 1/2 square root of 3 over 2. Cosine, sine. Tan is y over x. This one is not as complicated. Square root of 3 over 2 divided by 1/2. We can do this multiple ways. Dividing by 1/2 is like multiplying by 2, and the tan is the square root of 3. Okay, so I hope this helps. I am going to, I guess you can always pause, so I'm going to start over. I'm just going to remind you that just like sine and cosine repeat, the tan values are either 0, positive or negative 1, positive or negative root 3 over 3, or positive or negative root 3. It's one of these values, right? Because since you're always working with these values, positive or negative, and of course 0 and 1, when you divide the negatives or the positive, etc., you're always going to get one of these 1, 2, 3, 4, 5, 6, 7. There's 7 possible values for tan. And I guess I can end with what the original question was. Okay, so this came up in one of the Math Help Services pages. I don't know which one. So basically, oops, okay. I'm going to draw not the entire circle, 5 pi over 6. So that's 1 pi over 6, 2 pi over 6, 3, 4 right here. So this is 5 pi over 6. Okay. So I don't know if you caught my trick. If it starts with a 6, it starts with 3 and 2. No, if it starts with a 6. If the denominator is 6, the first value is always the one with the 3 and the 2. And the second value is a half. Except we went negative, positive. So this one is negative. So the only difference, I'm going to write cosine, sine. This would be a half negative, right? So the only difference is that it's the exact same question I did before, except it's negative. Okay, so I hope this helps. This was how to find tan of any angle using the unit circle.